All right, good day. This is Math 1 to 16-17 exam question number 5. If you have the past question, my number 5 may not necessarily be your number 5. Okay. So the question says, evaluate limit as x approaches infinity of minus 15x raised to power 3 plus 4x raised to power 2 minus 6. Everything divided by 6x raised to power 3 minus x raised to power 2 minus 4. So we are going to do that now. Solution. Now, having given this, first thing I will do, I'll divide through, I'll divide through every single term in this expression by x raised to power 3. I'll divide through by x raised to power 3. What that means is I'll divide everything in the numerator by x raised to power 3, divide everything in the denominator by x raised to power 3. The reason I'll do this is so that I'll end up having 1 over x in some of the terms. And because I know limits to infinity, limit as x approaches infinity of 1 over x equals to what? 0. Because if you don't get something like this and you start substituting, like say 15 of infinity raised by 3, you won't be able to determine this. So here is the more accurate way to go. So solution. So if I divide through by x raised to power 3, I'll be having this limit as x approaches what? Infinity. We're having minus 15x raised to power 3 divided by x raised to power 3 plus 4x raised to power 2 divided by x raised to power 3 minus 6 over x raised to power of what? 3. Everything divided by 6x raised to power 3 divided by x raised to power 3 minus x raised to power 2 divided by x raised to power 3 minus 4 divided by x raised to power 3. You know, if we do this kind of division, nothing has changed. This expression is still the same here. Nothing has changed because if you check, what we actually did was like say 1 over x raised to power 3 into minus 15 x raised to power 3 plus 4 x raised to power 3 that over the same 1 over x raised to power 3 into 6x raised to power 3 minus x blah 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 blah. So you see, this one will cancel this one, so it's still the same thing. So this one is the same as this one, so it's not something to be worried about. Say, no. So we continue. So now, if you cancel, if you reduce that move, we're having limit x approaches infinity. X raised to power 3 will cancel x raised to power 3. The numerator there will remain minus 15 plus 2 x raised to power 2. This one will cancel 1x will be remaining on the bottom. 4 into 1 over x. Okay. Minus 6 into 1 over x raised to the power of 3. Everything divided by, this one will cancel this one. You'll be having 6 minus, this one will cancel and 1x will remain on the bottom, minus 1 over x This would be 4x raised to the power of 3. Now, having established that limit of 1 over x as x approaches infinity equals to 0. So now that's standard theory for limits. Now, so this limit will start going in here. 15 minus 15 will remain where it is, plus 4 times limit of 1 over x will give us 0. That's limit of 1 over infinity. Limit of 1 over infinity, 1 over x, the approaching infinity is 0. So put 0 here. Minus 6 into, it's still the same here, it's still the same. 6 into 1 over x raised to 3, like, or you can solve here. It's still the same thing, raised to 3. So limit of this one is 0. 0. So everything, forgot to put my limit there. Okay, 6 minus limit of 1 over x there will give you 0 as x approaches infinity, minus 4 times limit of 1 over x raised by 3, that will still give you 0. So finally, all you'll be having is minus 15 plus 0 divided by 6 minus 0 will go, this one will go, 6 minus 0. What you are being left is minus what? 15 over 6, which is the same thing as if 3 divide 15, that will be 5. Divide this 2 minus 5 over 2. But in the option there, what you find is minus 15 over 6. You will not find minus 5 over 2, but this and this are the same. So this is the correct answer. So therefore, limit of that equals to what? Minus 15 over 6. That's the limit of this as the x approaching infinity equals to minus 15 over 6. What is that for that?